right, good morning. I'll stand back a little bit from the mic there. All right. Good morning. Welcome to the Worldwide Public Sector Summit here in Washington, D.C. Really great to see everyone here this morning. We've got a jam-packed day full of presentations and sessions from a number of AWS technical team members, service team members. We've flown in people from all over the world to be here to talk to you about all of our latest and greatest services and features. We've got a ton of partners that will also be here presenting, and so it's really great to have everyone here in this first session on day one. Oops, get the mic a little bit fixed here. All right, a little too loud in the back, you good? All right, okay, great. So I have again, the distinct honor of kicking things off here on our DevOps and serverless track. So throughout the day today, there's going to be a number of presentations talking about all the great tools that Amazon Web Services has and our partners have delivered for you, so you can build some really awesome applications inside of the cloud. So why are we here today for this particular presentation? So in general, over the last 20, going back the last 20, 30 years of software development, typically building, releasing new software code, and then getting a new product out or updating an existing production environment was something that was the time to deploy was measured in something along the lines of months, if not years. Weeks was something to strive for, but all of that has changed in the last 5-10 years. In the last 5 years, especially, with all the tooling that's available and the scale of Amazon Web Services in the cloud, now we're measuring our deployments in literally hours, if not minutes or seconds. We're in a world now today where developers and system operators are able to update their production environments in literally minutes, right? So going from a new software change to testing it, to doing some integration work on that, the new release, and then getting it deployed into production, sometimes on a server fleet that's scaled out to 20,000 or more nodes, can literally happen in minutes now. So we're going to talk during this presentation, we're going to give you an overview of how we see DevOps and some of the tools that we've delivered in order to allow all the great engineers and developers here in this room to get your code out into a production environment and out to your end users as quickly as possible. And with me today, I'm really happy to have the team from the IRS and MITRE to talk about how they've used DevOps to innovate on behalf of the American taxpayers. So I think there's been a lot of amazing work done in the U.S. federal government over the last few years to really truly embrace a new way of deploying code and getting it out there for the end users to have a better experience with their data and to really make their data more widely available for a variety of reasons. And we're really happy to have the IRS here today to talk about some of the work they've been doing behind the scenes to really innovate and really transform the way they operate. Not just in their software development processes, but how they've actually used Amazon Web Services to develop new services and features for their end users. So here's kind of a broad outline of what we're going to talk about in the first 30 minutes or so. All right, we're going to talk, first of all, let's talk about DevOps, what it is, what it isn't. We're going to talk a little bit about Amazon.com's journey into DevOps. We'll talk about our internal story. Amazon.com, of course, is a company that's been around for about 20 years, but we've actually we've adopted the DevOps philosophy about 15 years ago, so we'll talk a little bit about how that journey worked. And then we'll talk a little bit about some of the Amazon Web Services code services and how you might be able to utilize those for your environments. So, as I said earlier when I first kicked off the session, software is moving faster today. Most commercial companies and startups are really readily embracing DevOps as a way to speed up innovation and to provide new features and offerings to their end users. And really, it's been very disruptive actually in the last 3-4 years. We move into this world where now you can get software out to your end user from idea to designing it on the whiteboard to doing some initial code, or writing some initial code, testing it out, and then getting it out to production at a global scale, and have that all done within a very, very short period of time has been hugely disruptive, to the point where if you look in the fintech space, you have very, very small financial tech, fintech companies that are now taking on some of the world's largest banks. If you look in the hotel industry, how Airbnb has disrupted the whole hotel industry, or the ride-sharing industry, Uber and Lyft, and how they're disrupting. So it's really been amazing how transformative software development in the cloud has been, and just in our daily lives. And then here for our public sector audience, it's been really interesting to see how both nonprofits, federal government, local, state government organizations, and of course educational institutions worldwide have really embraced this model to deliver better, higher quality services to their customers. So why does it matter? If DevOps enables you to do things faster and more frequently, right? So you look at a typical high-performing IT organization, one of our typical Amazon Web Services customers that's very mature, been in the cloud for maybe a few years now. They're typically doing deployments once 30 times more frequently. The lead time to deployments is 200x shorter. The failures that they have when they develop new code and test it and then get it deployed, failures are greatly reduced. And of course, if you do have an issue where you need to roll back or you need to recover, you're seeing an amazing increase in recovery results, identifying failures, and remediating those as quickly as possible. So, right, what is it? Let's kind of define this, right? DevOps, it's kind of taken on a different meaning to different organizations and groups. Here at Amazon Web Services, we like to talk about it in a certain way. To us, it's really a combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. So evolving and improving products at a faster pace than organizations using traditional software development and infrastructure management processes, right? This speed enables organizations to better serve their customers or end users. And if you're in the commercial world, you're obviously very interested in competing with others in the market. If you're in the government world, you're obviously interested in delivering high quality services to your constituents. And if you're in the education background or nonprofit background, right, you're really out there serving the world and educating the people that are going to build and manage and operate large-scale systems for those around the globe. So for us, right, when we think about DevOps, it's where Amazon Web Services comes into play is that we really want to, number one, we want to evangelize best practices, and we want to make those best practices widely available to all of our million-plus customers. But we also want to give you the tooling that really enables you to speed up deployments, speed up testing, and then get your code out across the globe. So Dev and Ops, right, traditionally in most organizations in the commercial sector or in the government, and in government there's a lot of different things going on there with the way acquisition works and separation of duties, roles and responsibilities. But typically what you see out there is that there's a silo. You have between your development team and your infrastructure operations team. So typically you have your development team that's going out writing code, and they're kind of testing that code on their laptop or on their desktop. Maybe they have access to some infrastructure that they can use for dev test purposes. Sometimes literally all they have is their laptop, and then you have the operations community silo that's typically they get handed the code, it gets thrown over the fence. They go and deploy the code, and then if something breaks, the operators go and point the finger at the developers. And if the developers don't like how their code is performing in production, they go and point their fingers at operations. So really, the first step to really embracing DevOps mentality in your organization is really to kind of shift your culture a little bit. And for some organizations, that's going to be a radical shift. For other organizations, it's going to be a gradual, phased approach. For every organization, it's going to be different. You're not in some companies or organizations, you're not necessarily going to immediately, knock down all the barriers and walls. But the hope or the idea is that your leadership and your teams will want to will embrace this philosophy where people are now sharing responsibility for the quality of the product that they're deploying and sharing responsibility for the operations of that production environment. So it's not just the developers throwing their code over the operations and operations going and deploying that code, but now really it's the developers and the operations community coming together to make sure that, number one, the end users have a really, really great experience. And if they're not having a great experience, to identify where the issues are and get better quality code or features or services out there for your community. And the key thing right there is, you have to have the first key shift you need to make. If your organization right now, if you're sitting here and you're thinking about your own teams that you work with day to day, and you have some of these kind of silos that exist today, really the first key shift you have to make in your culture is this idea of ownership, right? So developers and operations teams, it's not just, developers own the code and operations owns the infrastructure. It's having this shared responsibility that you're going to own the product together as a team. You still might have organizational chains of command where not everyone's going to fall under the same leader. That might not ever happen in your organization because of various reasons, but if you at least have this mentality going into a new product or into managing or deploying a new application or service, that everyone's going to work together and own this, and that's a really huge first step, and that's really, really important. And then the other key thing, right, is visibility and communication, right? Often finger pointing in organizations, right? That's because one side doesn't know what the other is doing, and so you need to start breaking down those walls and barriers between what the operations community is doing and what they know, and versus what the developers are working on and their knowledge of how a system works or an application is written. So this is really, really important, right? The developers and operations communities should really be talking together, talking very frequently, talking at the same language. They should have shared visibility into, if you want to get into the technical side, shared visibility into metrics, shared visibility into application failures, shared visibility into the feedback that users are giving about the service or application that you've delivered to them, right? So when you get feedback about your application, your service, that should be widely available to all those that are using that software or that service. So in Amazon.com, I'm going to talk a little bit about Amazon, where we came from. Amazon.com, the retail website that we all know and love, 2-day shipping, Amazon Prime, great stuff, right? It really, if you look at Amazon.com 15 years ago, it was a very, very monolithic architecture. Internally at Amazon, you kind of had this, single massive website, and the various services and sub-services and modules that made up Amazon.com were kind of not very well defined. Very, very quickly, we realized internally that we were not going to be able to scale out our website. Number one, we weren't going to, from an infrastructure standpoint, just trying to scale out a website that has millions and millions of people clicking and ordering millions of products every day. We're not going to be able to scale that out infrastructure-wise if we don't kind of start splitting up responsibilities for who's doing what. The other thing we realize is that if we're going to keep innovating, we need to have small and nimble teams that can move fast. And so we very early on in Amazon.com, we embraced the idea of a microservices architecture where you have very, very discrete teams working on very specific parts of the overall website or the customer experience in order to innovate and improve and scale that out. So getting into kind of continuous integration, continuous delivery and deployment, what we found is that, for us, this is kind of where everyone kind of starts. Once you kind of accepted or embraced the fact that you need to deploy code faster, that you need to get your latest and greatest innovations out to the world quicker, most organizations start with continuous integration, right? And actually, even if you still have some of those silos in place in your organization, you probably have some type of form of continuous integration pipeline going on in your organization. And really, what is continuous integration? So kind of how do you define that? It's generally, you have code, you check it into a source control repository like GitHub, or in Amazon, we have Amazon AWS Code Commit. You check your code in, and then maybe you do some build on that code, like if it's Java, you might have to do an artifact build, and then you do some testing. And generally, that's kind of where, build and maybe a little bit of testing, that's where continuous integration kind of stops. At that point, most organizations, this is kind of the status quo for the last 15, 20 years, is at that point, you go into change control, you have maybe a change control management board, you might have a multi-step, human-gated process where, multiple people have to review what you've done, and that even though you've deployed a new release of your code, or even though you've developed a new release of your code, that code build might not actually get deployed, for many weeks or if not months. And in some cases, that release, if it's a major release, won't see the public light for a year. That's kind of how things are status quo today in many organizations. But when you start getting into continuous delivery and deployment, right, what you're doing at this point is you're not stopping with just your build and your testing. You're also now sending your latest code release out into staging. And then eventually, after you've done some testing at a small scale or a certain subset of your users, and you feel comfortable with what you've released through some automation tools that are doing unit testing or doing some fuzzing or some other technique to ensure that the code is generally error-free or bug-free. Maybe not 100% perfect, but it's good enough to send out to the public. At that point, your tooling is going to send that code into production. And so really, really nimble organizations are actually able to build these CI/CD pipelines where their developer goes and writes up a new piece of code, they check it in, and then they're able to get that out and deploy it into production within minutes. In some organizations, you might still have to have a human gate, a manual gate, or a kind of a stoplight somewhere in that process, maybe for a security review. That's still kind of normal for depending on the sensitivity of the data your application handles. But the idea is that most of this pipeline is automated and seamless so that the developers at this point are really empowered, and your infrastructure operations folks are really empowered because, number one, everyone has shared metrics and a shared understanding and a shared reality of what's going on, who's deploying what, where it's going. There's a lot of collaboration, a lot of communication, and more importantly, everything's been automated. So one of the cool things about AWS, right, is the whole concept and idea of infrastructure as code. So up until now, I've been kind of talking about services and applications and deploying those, right? So if you have a web application, or if you're delivering some type of big data, or you have some type of big data analytics cluster, right, and you have some front end for that for analysts to operate on. Kind of up to them, the last 15 minutes been mainly kind of focused on these software applications or services. But, the other cool thing is with AWS, because everything's API driven, and because we give you an easy way through CloudFormation and other techniques to represent your infrastructure in either JSON or YAML or in some format where you can reproduce your infrastructure very quickly, you can actually now treat your infrastructure as something that you manage through a DevOps pipeline and process. In fact, you could even combine your software releases with your infrastructure code as well, so that when you go and deploy a new release of your software, you're actually deploying it on an exact replica infrastructure as your production environment. So now you can dynamically stand up staging environments and beta or gamma environments on the fly to test out your code. And then once you've passed all your testing, part of your CI/CD pipeline process is that once the testing's done, you tear down that infrastructure, and then you can kind of, and so you're not paying for it, and so that you can always start from a fresh copy of it or a fresh version of your latest production environment. So infrastructure should be something that you're managing in AWS is the same way that you're managing your code. You check it into GitHub or Code Commit. You have different releases of your code. You test out your code, and you share those environments between developers and operators, so that you can iterate and innovate and improve on your infrastructure to help you better scale out your overall services. All right, so we talked a lot about that shared reality or shared responsibility, and that all starts with tracking and analyzing metrics and collecting log data. This is really, really, really important. From a tools and process perspective, you should have some very well understood metrics for your application. And you're going to start out with maybe some very rudimentary metrics from the infrastructure side. You might check CPU utilization, you might check memory utilization, network utilization. But eventually, as you mature and evolve inside of AWS, you're going to be looking at a lot of other interesting metrics like in and out operations. You're going to be looking at how you handle cache. There are a lot of interesting infrastructure things that you can start really diving into to help get those improvements in the user experience through efficiencies gained through infrastructure, constantly evolving your infrastructure. And then on the application side of the house, you're going to start tracking things like, of course, the standard stuff, how many people have visited the website, how long did it take for a user to input something new into a form and then have that data inputted into the database? What was the latency between user input and user result? These are the type of metrics that you want to start collecting and analyzing constantly so that you can get those gains and improvements in your application and to understand the performance of your application in real time to help you make better decisions about your future code releases and how you're going to deploy your infrastructure. So, to recap, benefits of DevOps: improved collaboration, rapid delivery, scale, speed, security, reliability. So let's look really quickly at Amazon.com. So 2001, monolithic architecture, again, very hierarchical organization. This is kind of our journey and how we shifted, and maybe this will kind of inspire some of the folks in this room to kind of think about how to change the way some of your organizations operate. So what we realized very quickly is we needed to start separating out the Amazon.com website, and not just Amazon.com, but a number of the other services we deploy. And we actually went to this interesting model where we now deliver decoupled services using the two pizza team concept. And if you haven't heard us give this talk before or speak about the two pizza teams, it's generally the idea that that if you really want to move fast and you want to be agile and you want to be nimble, you want to keep your teams pretty small, and somewhere around 5 to 10 to 15 people. Basically, you don't want to have more people on your team than two pizzas can feed. And the idea there is that this team is going to be responsible, that this team is not just responsible for writing code, but they're also going to manage their own infrastructure. And they're going to be responsible for the entire product, or if it's a very, very large service like, say, Amazon S3, they're going to be responsible for a specific subset of Amazon S3, some of the features or services of Amazon S3. And this model has worked really, really great for us because now individual teams can operate at the speed of their innovation cycle. Some services and teams will find themselves in an area where they're doing 10 to 15 to 20 deployments per day, and then there's other services that have that will actually be deploying somewhere along the order of magnitude of 100 times per day, actually making live deployments into production, making 100 changes to their code per day, and then deploying that live out to AWS or to Amazon.com. And so the idea is that if you have these kind of small teams, they can deploy at their speed based off of their product lifecycle and their roadmap. And it's also, again, getting back to ownership, right? If these are the teams that are responsible wholly for that product or service, then they can be accountable to their own individual service team, technical goals, and business metrics and roadmaps. So this has worked really, really great for us. And developers really love this model, right? So obviously one of the challenges in the tech community right now is inspiring and retaining talent, top talent, and attracting that talent. And one of the things we found inside of Amazon is that developers were, under this model, were releasing a lot faster than ever, to the point where if you kind of aggregate all of the deployments we were doing in AWS in 2014, we were now in the tens of thousands of deployments per day. So in 2009, we ran a study actually to find out where inefficiencies might still exist. And even though we kind of moved to this, microservices architecture and we had these service teams, we were still seeing some delays between when code was being written, when code was, the building of the code, and then deploying to the test, and then getting it deployed to production. We were just kind of waiting and waiting and waiting, minutes, days. We had kind of, the microservices and the small service teams was working really well, but we were still finding these latencies or delays between different steps of the process in Amazon. And we realized really quickly this is something we've got to fix this, because again, developers and operations folks, they want to have an impact, and they want to make an impact quickly. Having to wait days or weeks to see the results of your work, that can be very frustrating. So we need to kick out some of these delays and find these inefficiencies and try to get our deployments from software release out to production down to hours. So in Amazon, we built a lot of tools in order to enable us to do this. And I'll talk about one of the tools really quickly, because it's a really cool tool that we actually made available to all of our customers to use. So one of these tools we built was pipelines. First of all, we had this code deployment tool called Apollo, and that was really, really great. The Apollo tool that we used internally was really, really great at deploying code at a massive scale, and it has built-in functionality to roll back code so that if your users started reporting a lot of errors, or your unit testing wasn't going so well, or once you got to a certain scale, if you started hitting some scaling limitations with your infrastructure or code, Apollo was really, really good at rolling back code and deploying code and handling all of that at a very massive scale. But we realized, again, going back to those previous slide, where we're seeing these kind of delays between the process from software commit to software testing to going out and staging. These delays here was a result of a lack of automated orchestration, and that's where pipelines come into place. Pipelines is an internal tool we built to automate actions and transitions from commit to build to testing to deploy to production. And obviously the benefits of this were immediately realized. Again, like I talked about earlier, how we eventually, with the microservices and 2 service teams, we were getting to tens of thousands, 50,000 deployments per day. Once we had pipelines and some other tools that we built internally, in 2014, with thousands of service teams across Amazon, all building microservices, practicing continuous delivery, using Apollo and pipelines, with all these many environments, staging and beta and production. And oh, by the way, these staging and beta environments, because remember, this is the cloud, these are not permanent environments. They're stood up and taken down so that we can conserve resources and reutilize resources that are not being fully utilized. So in 2014, we actually got to the point where we actually did 50 million deploys. And these are deploys where, again, code went from developer on his laptop or her laptop to committing that, to getting it out to Amazon.com or getting it out to the AWS immediately. Every year we perform a survey inside of Amazon. We do a tech survey. Tens of thousands of folks from our tech community take the survey. And the one result that always screams out as a kind of key highlight of that tech survey is everyone loves pipelines. So this has been really, really great. Continuous delivery equals happy developers, and we have the metrics in the survey results to prove that. So it's great. So where do you start? So again, we spent the last 5-10 minutes talking about all the cool tools Amazon built. What have we, for ourselves? What do we have available for you to use? So one cool thing we just released is AWS Code Star. And Code Star allows you to quickly develop and build and deploy applications on AWS. So if you have a small team of developers and folks that want to just get started working on a project very, very quickly, you can start a project. You can integrate the Code Star tooling with a third-party IDE or software development tool. You can start, get a code commit repository up and running, and then start shipping code and getting it deployed in Amazon infrastructure within minutes. So this has been a really, really awesome feature that we've released in the last couple months to really enable better project teams to get going faster. So we also have a whole portfolio of what we call the AWS Code Services. Now, the cool thing about these code services is that they're interchangeable. We have CodeStar, Code Pipeline, Code Deploy, Code Commit, Code Build. If one of these services or features is something that you're not interested in using because you're already using GitHub, or if you're already a big fan of Jenkins or some other software, you can continue to use that. You can kind of pick and choose which one of these services you use. Let me give you a brief description of where these kind of all fit in. So going back to our software release steps, right, we have source, build, test, and production. So code commit is highly scalable code repository where you can commit your code, and it's basically built on top of Amazon S3. So people love S3 because it's highly scalable, cheap storage. The other cool thing they like about S3 is the ability to encrypt your data using encryption keys that you manage. So code commit is essentially a code repository in the cloud with permissions and controls and encryption that you can control. For building, we have AWS Code Build. So again, if you want an automated service that will help you build your code, if you're developing in Java, for example, and you need to do a code build in Java, Code Build can help do that in an automated manner. And this really saves you from having to run or manage infrastructure. And then for testing, there's tons of third-party testing tools out there, and we've worked with a number of our partners to make sure that we can integrate with all those tools. And then for production deployments, we have AWS Code Deploy. And the cool thing about Code Deploy is not only can you deploy code on Amazon EC2, which is virtual machines inside of the cloud, you could actually also use Code Deploy to deploy code to your on-premise servers. In fact, even if you have a laptop or that you're just doing some testing with on your back at home, you can actually use Code Deploy to deploy new code to your laptop or your server in your basement, or to hundreds of servers or thousands of servers that you still have running and operating in an existing data center. So Code Deploy is not just contingent on EC2. You can actually deploy to both EC2 and to a production data center. And so when you kind of put Code Pipeline into this whole mix, right? Code Pipeline is the orchestrator for automating the movement of your code through all of these steps. And again, a code pipeline has various stages that you can define with actions that you can define. And there might be, again, like I said earlier, there might be a point where you're going to take a pause in releasing your code to have a manual check by, whether it's a change management board or a security review. You can actually program it into pipelines where you might get through your source code commit, you get through building, you get through testing, but then right before you deploy to production, right before you kick off that code deploy step, you can have kind of a human gate where some other team or you're going to do a higher level review within your existing team to make sure that what you're deploying to production is ready to go, it's safe, secure, and it is the right decision and then CodeStar, where that kind of falls into all of this, is CodeStar orchestrates all of these services to quickly allow development teams, DevOps teams to collaborate. So if you look at our overall portfolio, this is kind of just a very, very small sampling of what you can do with DevOps inside of AWS. And of course, you have Code Commit, Code Deploy, Code Build, Code Pipeline, and CodeStar. But then you also have, for infrastructure management and for your infrastructure as code operations, you have things like CloudFormation, you have OpsWorks. And then, of course, for monitoring and metrics and log collection, you've got things like AWS Config, AWS CloudTrail, CloudWatch, and then another service we have, which is really, really great. Developers love this service. DevOps teams love this service. Is Elastic Beanstalk for managing EC2 infrastructure at scale. So if you want more information on CodeStar or some of these other services, go to our website, take a look at CodeStar. Take a look at Code Build, Code Commit, and again, it's all of these services are interchangeable with third-party tooling. So now I'm really, really pleased to bring a customer up on this stage who's actually shifted to using DevOps to help improve the taxpayer experience. So I'm really, really pleased to introduce Michelle Causey from the IRS, the director of their user experience department. Michelle, great to have you here. Thanks.
Good morning. thank you for having us here today. So I wanted to really just talk about the business case for using Amazon Web Services and DevOps at the IRS to improve the taxpayer experience. So reaching back a little bit, the Office of Online Services within the IRS was created in 2011. The IRS recognized that we needed to find a way to improve the taxpayer experience and change the way that we do business day to day. And so as a result, the IRS really wanted to improve digital self-service capabilities in an effort to maximize more cost-efficient service channels. So how are we going to do that? So traditionally speaking, the IRS used to develop products and services using a waterfall development methodology. That methodology was often constrained by what we have known as the filing season for the IRS. So we had a very linear timeline and development cycle within a very finite window. And so in order to protect the integrity of our tax administration systems, we did not really have the luxury to interact with taxpayers and or do essential research and or learn how users would behave or adopt new products and services. And so the development process didn't really lend itself to true UX. We often would develop new products and services using static designs. I will tell you from personal experience, I used to be the product manager for Where's My Refund? And in order for me to ensure new designs with developers, I often had to work with wireframes on PowerPoint presentations. So it was difficult to assess the interactions or how an application would behave in production. And more importantly, it was difficult to really leverage data and metrics and analytics to really understand taxpayer behaviors and be able to predict expectations. And additionally, due to our technological constraints, sometimes we, in order to conduct stakeholder interviews or reviews of what we were proposing to deliver to the public, sometimes we were restricted to a single laptop, similar to what you have here in a presentation to say, okay, do you agree? Does this look like something that can be easily digested by the public? So what are some additional impacts to that approach? It was very difficult for us from a development perspective to really have an appreciation and understanding of the evolving needs of taxpayers. So whether or not products or services were actually meeting the needs of the taxpayers so they could fill their tax liability and tax obligations in order for taxpayers to receive information in a timely manner and also to be able to monitor adoption. Oftentimes, we would not be able to understand and really assess taxpayer behavior until after a product or service was in production. And so we have low adoption rates, then we're not meeting the needs and we're not serving the public, and so that often be problematic. We had no way to really conduct A/B testing. There was no way to really understand whether or not the approach that or the path that we were going down was actually correct and or would meet the needs of the public. And so oftentimes we would have to wait to the next waterfall development life cycle in order to make improvements, and we did not have that luxury. And again, from a development perspective, we have a lot of geographically dispersed employees. So if we needed to leverage expertise from another area, that was often very difficult to do because, again, we were sharing very static designs and trying to convey the approach and or the vision that we had for our products and services via PowerPoint presentations and other static designs. So that brings us to IRS Labs. So the Amazon Web Services solution was actually brought to us in partnership with the MITRE Corporation, our federally funded research development center partner. And they have been a partner with us ever since 2011, and they recognized the need that we wanted to move development forward. We wanted to look at agile practices, iterative development, and real-time development so that we can provide solutions immediately to the public versus waiting for long development life cycles, which often extended beyond a year in order to provide a capability to the public. So prototyping. One of the benefits of Amazon Web Services or our DevOps environment was that we now have the capability where we can launch an HTML application or spin up an instance for a web application container within minutes. And this has proved phenomenally beneficial for our development times. We are now able to prototype in real time and really experiment in a secure environment. And more importantly, from a collaboration perspective, we can share any prototype with any partner. You do not have to have any restrictions from a security perspective. Historically speaking, our developers had to be cleared if they weren't IRS employees, and we did not have the ability to collaborate with external stakeholders, namely taxpayers. So how has this changed our business? We now have the ability to get real-time feedback from our taxpayers. We can take any of our prototypes, we can iterate on the content, we can iterate on the experience, the digital capabilities, as well as leverage analytics that we can use to really assess what it is that we are providing to the taxpayer community. We did not have that capability before. And so we have a number of success stories that we can share with you. The first step I want to talk about is e-authentication. E-authentication, or secure access, is our method for allowing taxpayers to access secure applications such as get transcripts. So 2016 filing season, we relaunched get transcripts, making real-time updates in a matter of weeks to the application, improving the journey of the application, improving the content based on taxpayer feedback. We were able to meet with over 30 taxpayers across the United States over a 4-week period, and we were able to develop in real time with our prototypes a solution that increased adoption for this particular application, improving the user experience for taxpayers. And we were able to launch during filing season, no longer with the restriction of the waterfall development lifecycle. On account, which is a product that we've launched recently to allow taxpayers to access their balance due, we are continuously developing in sprints of 2-week cycles where we are iterating on features, capabilities, content, and being able to provide taxpayers, again, through the use of user experience testing, new capabilities. We have what's called program increment meetings, which are the equivalent of our sprints, and we are delivering new functionality in 2 to 4 week increments to the public. Again, accelerating our developing lifecycle. On IRS Direct Pay, that's a capability that we provide to the public to pay tax obligations via ACH debit in a secure environment. During phase 1 of Direct Pay in 2014, we were able to iterate on designs in order to find an experience that taxpayers could navigate that was intuitive, delightful, based and predicated on user research and metrics. So some of these success stories are not limited. We do have a number of other products that we're developing as well using the same methodology, but the benefit here, or the lesson here, is that we're no longer restricted by the waterfall lifecycle. We can get real-time impact, and we can simulate the experience that the taxpayers will actually see and seek feedback so that we can develop solutions that they will use. So how do our teams work with labs? This is the journey of the user experience designer role. It is essential that we analyze our product requirements, that we understand from a metrics perspective, historical analytics, that we do our research and our due diligence to understand taxpayer behavior or user behavior. So once we do that analysis, we then work to conceptualize or design our products and services using low-end fidelity prototypes and wireframes to high-end fidelity prototypes and wireframes. Leveraging Amazon Web Services, or what we market as IRS Labs, we are able to share these prototypes with stakeholders internal to the agency. We are also able to leverage these prototypes and share with them external with taxpayers, and oftentimes members on the Hill who are interested in the progress that we're making in terms of improving taxpayer service. And then in addition, we are constantly testing. Test, test, test. Test, seek feedback, iterate, and then produce. And if you notice by this diagram, the little arrow continues because we're constantly seeking feedback. That feedback is essential and it's important. Once we produce, design does not stop. We have to evaluate the metrics and the analytics to define whether or not we are addressing taxpayer needs and behaviors. And so we leverage that data, we reanalyze it again, and then the feedback loop continues. So this experience has really been beneficial to the service, and it has really streamlined our partnership with our developers inside the service. Because now we have this new platform, we're able to collaborate more cohesively with our developers. We're able to provide them with code that is often tested with 508s and other requirements, so that development can actually be streamlined. It doesn't take us nowhere near as long as before. And so to speak a little bit more about the development process, I'm going to turn it over to Carlton from MITRE, our FFRDC partner, and he's going to explain to you a little bit more in depth the journey from a development perspective. Carlton?
So we support a wide range of skills and abilities for our software developers. Because of various reasons, whether they just aren't a pure software developer, they just want to use a basic tool like Azure to generate a wireframe, or because of various rules that IRS has to follow to protect the integrity of the tax data and everything else, they may not have access to all the tools that a full stack developer would have. So if they don't have Git or they don't have a development environment, we can still support them. And the method is pretty much still the same sort of pipeline of uploading some code or just uploading HTML and having our service wrap it in a lightweight prototype framework to push it out as code. As Michelle mentioned, we have a secure mechanism to share all that information with all of our stakeholders so that we're not limited to having to bring a laptop around to show it to the next person in the chain. At a glance, to quickly touch on some of the AWS services we're using, there are the fairly traditional EC2 Route 53 for DNS, SES so that we can handle things like invitations and notifications for GitLab check-in. But we've recently moved from a alternate Docker-based approach to Elastic Container Services because that had a whole lot of value for us from the point of view of accreditation and not having to rewrite code, that we could just leverage what Amazon gave us. We're also using Amazon S3, and we're investigating Amazon RDS instead of our current Mongo approach for allowing prototype users who want to actually go beyond just a static environment to something that is mutable and can handle dynamic code. But we don't tie them to any one technology. They can be a Ruby developer, a Node developer, a Java developer, a Python developer. If they understand Docker, we can support just dropping their container and running it. If they don't want to tie themselves to Docker, they don't have to. And so we can very rapidly support lots of different prototypes using the efficiency Docker and ECS provides us. And we're built on that sort of same microservices-based approach that Jim talked about in his DevOps brief. We're using our own code, such as UserLab, Persona. We're doing stuff with just an Nginx box sitting out there. We have our own authentication piece that handles making sure all of the prototypes are all are protected in the same way, as opposed to leaving it up to the prototypes to handle authentication, which is just asking for one person to make a mistake and leaving themselves open. We're also using some various back-end services that are similar to what Jim talked about from AWS, and we're looking at which ones will make sense to migrate to the emerging AWS systems. But currently, we're using the Elastic Container Repository, the Elastic Container Service, but we're using GitLab instead of the AWS Code tools just because we had this up before that, and we're looking at it, but we really like how we're handling user and passwords and not having to tie ourselves to AWS for that piece. And so we'll probably not migrate that. And I think I'm out of time.
All right, great. So, well, thanks very much, Carlton. So we're gonna thanks everyone for stopping in for the session today. We're gonna be available for questions here on the side of the stage. I hope you all have a good conference, and thanks, and enjoy the rest of your time here at the AWS Public Sector Summit. Thanks.